Hello all and welcome back. In this video, we are going to cover Amazon SQS, that is Simple Queue Service FIFO queues. Amazon SQS is a fully managed, highly available, highly scalable, fault-tolerant, secure, distributed queue system, and it acts as a buffer and enables loose coupling between the producer and the consumer. SQS supports two types of queues, standard and FIFO. SQS FIFO queue provides enhanced messaging between applications with additional features. It supports FIFO or first in first out delivery, that is, the order in which the messages are sent and received are strictly preserved. Messages can be grouped into distinct ordered bundles within a FIFO queue. Message group ID is the tag that specifies that a message belongs to a specific message group. Message group ID is the tag that specifies that a message belongs to a specific message group. And for each message group ID, all messages are sent and received in strict order. However, messages within different message group IDs might be sent and received out of order. For an example, in a financial domain, you can use the customer ID as the message group ID, ensuring that the customer transactions and payments are processed in a strict order. Every message can be associated with a message group ID, without which the action fails. SQS delivers the messages in the order in which they arrive for processing if multiple hosts send messages with the same message group ID. Exactly once processing, where a message is delivered once and only once and remains available until consumer processes and deletes it. SQS provides deduplication functionality that prevents message producers from sending duplicates using message deduplication ID. Message deduplication ID is basically a token used for deduplication of the sent messages. If a message with a particular message deduplication ID is sent successfully, any messages sent with the same message deduplication ID are accepted but aren't delivered during the 5-minute deduplication interval. So basically, any duplicates introduced by the message producer are removed within a 5-minute deduplication interval. Message deduplication applies to an entire queue and not to individual message groups. FIFO also now supports content-based deduplication, where message deduplication ID is optional. SQS FIFO queue throughput is limited to 300 transactions per second, and it can be increased to 3000 with batching. It also now supports high throughput option. FIFO queue provides all the capabilities of standard queue, improve upon and complement the standard queue. However, FIFO queue has some limitation and restrictions. The queue name should end with .FIFO suffix. SQS buffered asynchronous client isn't currently supported by FIFO queues. FIFO queue also currently do not support events and services like auto-scaling lifecycle hooks, IoT rule actions, Lambda dead letter queues, and S3 event notifications. Also, FIFO queues don't serve messages from the same message group to more than one consumer at a time. In this demo, we are going to configure a simple queue service FIFO queue and send and receive messages through console. SQS provides queues for high throughput system-to-system distributed messaging, and it can be very helpful to build loosely coupled architectures. SQS allows producers to push messages to the queue and the messages are stored in the queue for the consumers to consume. They are not deleted until and unless they expire or are explicitly deleted by the consumers. Let's navigate to the SQS console. We already have a standard demo queue created from our previous demo. We'll now go ahead and create our first FIFO SQS queue. We need to select a type for the queue, and SQS supports standard and FIFO. Standard queues support unlimited throughput, at least once delivery, and best effort ordering, whereas FIFO queues guarantees exactly once delivery and first in first out delivery order, however at a much lower throughput. You can choose the queue type depending upon your use case. For this demo, we would be selecting the FIFO queue. Note, you can't change the queue type after you have created the queue. Queue name is case sensitive, and for the FIFO queue, it should end with a suffix .fifo. We will name the queue demo FIFO queue.fifo with the suffix. Let's deep dive into the configurations. Visibility timeout. Visibility timeout defines the period where SQS blocks the visibility of the message and prevents other consumers from consuming the message. If the message is not deleted by the consumer before the visibility timeout, the message would be available for the other consumers to consume. The default value is 30 seconds and the range supported is from 0 seconds to 12 hours. Message retention period. SQS automatically deletes messages that have been in a queue for more than maximum message retention period. They basically expire and are deleted. The default message retention period is 4 days and range from 1 minute to 14 days. Delivery delay. Delivery delay helps postpone the delivery of new messages to consumers for a number of seconds. The default is 0 seconds, where it is delivered immediately, and it can range from 0 seconds to 15 minutes. Maximum message size helps specify the message size in the queue. The range is from 1 KB to 256 KB, which is the max. Receive message wait time helps configure short and long polling. For the FIFO queue, you can configure additional settings. FIFO queue supports message deduplication using message deduplication ID. You can enable content-based deduplication as well. For content-based deduplication, where the message deduplication ID is optional, the default setting is disabled. You can enable high throughput FIFO to enable higher throughput for sending and receiving messages in the queue. It provides higher transactions per second for messages in FIFO queues. Enabling high throughput FIFO sets the deduplication scope to the message group, and FIFO throughput limit is set to per message group ID. You cannot change these settings. Encryption. SQS supports encryption in transit by default. SQS also supports encryption at rest using default SQS key, or you can configure it using the AWS Key Management KMS service. We will keep it enabled with encryption using the default Amazon SQS key. Access policy. Access policy is the SQS resource-based policy. Access policy defines the accounts, users, and roles that can access the queue. Access policy also defines the actions such as send message, receive message, and delete message that the users can have access to. The default basic policy only allows the queue owner to send and receive messages. You can configure more fine-grained access control using the advanced option. Let's keep it basic for now, which should be good for our demo. Read-write allow policy. The read-write allow policy specifies which source queues can access the dead letter queue. The read-write policy specifies the source queue, the dead letter queue, and the conditions under which the SQS moves these messages from the former to the later. If the consumer of the source queue fails to process the message a specified number of times. Dead letter queues can be used to receive undeliverable messages. SQS supports dead letter queues or DLQ, which other source queues can target for messages that can't be processed successfully. We are good with the configuration. Let's go ahead and create our first SQS FIFO queue. The FIFO queue has been successfully created. You can check the name, type, the ARN and the endpoint URL. We can use the endpoint URL to interact with the queue. Let's try to send and receive messages to the FIFO queue using console. Let's use send message to send few messages to the queue. For the first message, let's enter message body as message1 from console, message group ID as 1, and message deduplication ID as 1. We will not add any other message attributes for now. Let's send the message to the queue. And it's successfully delivered. For the second message, let's push messages with the same body and same duplication ID multiple times. Message body as message2 from console, message group ID as 2, and message deduplication ID as 2. Let's send this message. And it has been successfully delivered. Let's resend the same message multiple times. I've clipped it 4 times, so ideally now we have sent 5 messages to the SQS FIFO queue. Let's poll for the messages. We have received the messages. And if you see now, only 2 messages have been received, as the SQS FIFO queue now handles the duplicates. Any messages sent with the same message deduplication ID were accepted successfully but aren't delivered during the 5-minute deduplication interval. Let's check the body of the messages. And the first one matches the message 1 from console. And the second message shows the message 2 from console. However, it has a single copy, even though we tried to push in duplicates. Let's clean up the messages from the queue. And it has failed to clear. This is because the receipt handle has expired. Let's repoll for the messages. They should refresh the message receipt handles. And let's click back on the messages and delete them. And the message has been successfully deleted. So that's it for the SQS FIFO queues demo. SQS FIFO provides first in, first out, exactly once delivery, and can be great for use cases where these features are critical and required. I hope you liked the demo. Thank you all.
Alright, that was it. Thank you for watching. You can check out my website and connect me on LinkedIn and Twitter. If you enjoyed this video, please give it a thumbs up. For any feedback, please leave a comment down below. To see more videos like this in the future, hit the subscribe button. Thank you.